For topic two, we're going to talk about zero as an exponent. I've alluded to this a little bit when I was talking about the degree of a constant term, but now when we kind of wrap up this topic, I'll explain why the degree of a constant is what the degree of a constant is. So recall any number divided by itself is one, and this can be expanded to algebraic expressions. So if I had something like x plus 2, sorry, I've been itchy to death with allergies. If I have something like x plus 2 divided by x plus 2, anything divided by itself is 1, so that would still equal 1. So let's look at an example here. So consider the following. We have x to the third divided by x to the third. Okay, well, we know that because any non-zero expression divided by itself is 1, x to the third divided by itself is just 1. Okay, similarly, we just learned the quotient rule. So using the quotient rule, we would take x to the third divided by x to the third. We know that if we're dividing two expressions with the same base, we keep the base, we keep the x, and then we subtract the exponents. So 3 minus 3 ends up being x to the 0 power. Okay, seems reasonable. Well, if x to the third is equal to 1 and simultaneously equal to x to the 0, it kind of goes without saying that x to the 0 equals 1. And that is the 0 as an exponent rule, or the 0 exponent rule. So if b is any number other than 0, b to the 0 equals 1. Now, I don't want to say there's exceptions to this. There aren't exceptions to this at all. This is a fact. B to the 0 is 1. But you do have to be careful when you're looking at expressions that contain 0 as an exponent. Okay, so let's look at several examples here. So example 2 says, use the 0 exponent rule to simplify each expression. Well, we have 6 to the 0. Well, anything to the 0 power is just 1. So this equals 1. But then for part B, we have negative 6 to the 0. And this is where things get a little different. And you do have to be especially careful. Negative 6 to the 0 is negative 1 times 6 to the 0. Because that negative 6 is not in parentheses, that negative 1 is not part of that exponent. It's a separate factor. So we would have to treat this like negative 1 times 6 to the 0. Now, 6 to the 0 we know is 1 based on this rule that we've just learned. So this really becomes negative 1 times 1, or negative 1. So negative 6 to the 0 is actually negative 1 because the negative was not inside parentheses. Now, just to really blow your minds, or not, it depends. But for part C, we have negative 6 in parentheses now to the 0 power. And we already know that when dealing with exponents, and especially negative bases, if the negative is inside the parentheses, it's part of whatever the exponent is, okay? So this negative now is tied to that 6. They're like married together. You can't undo them because of those parentheses. And since that 0 is on the outside of the parentheses, that 0 applies to the negative 1 and to the 6, okay? It's almost like products to the powers rule. That 0 exponent applies to both parts of this. So in this case, this entire thing is to the 0 power. So this whole thing equals just 1, okay? So be really careful with something like A, B, and C. They look like they would all be the same, but there's subtle differences that make them slightly different, especially if you look at B and C. Okay, now let's look at part D. So for part D, we have 6 times x to the 0. So you have to notice there are two different factors here. This is the same thing as 6 times x to the 0. This 0 exponent has nothing to do with the 6. It applies only to the factor of x. So this would be the same as 6 times 1, which is 6. So 6 times x to the 0 is 6. But then again, just to blow your minds, if we look at part E, we have 6x in parentheses to the 0 power. Now we're dealing with a products to powers rule. So remember, products to powers rule, it's really obvious here. It's basically what's happening in part C as well, but it's really obvious in part E. This is really 6 to the 0 times x to the 0. Well, 6 to the 0 is 1. X to the 0 is 1, so this just equals 1. So here you're looking at the entire base of 6x. It's married together with those parentheses. That exponent of 0 says, hey, this thing has to equal 1. And we've proven it using the products to powers rule. So when you have 0 as an exponent, just be really, really careful, okay? Now, I did promise I would talk to you briefly about why the degree of non-zero constants is 0. Okay, so I don't really have a ton of room here. So recall the degree of non-zero constants is 0. Well, the reason for that kind of comes from this property right here. If I had something like 3x to the 0, okay, well, we know that that's really 3 times x to the 0, which is really 3 times 1, which is really just 3. So I would just write this as 3. But secretly behind the scenes, there could have been x to the 0 power. So this is why we would say the degree here is 0. Okay, that's kind of how I think of it anyway when we talk about the degree of a non-zero constant being 0. Technically, there's multiplication of a product of a variable to the 0 power. So that's why we get that. Okay.